So at the top of your paper, go ahead and write factoring. We're just going to remember some of the basics, and then, because we're in Math 3, there is a new type of factoring we have to learn, okay? Okay, the first type of factoring is greatest common factor. Oh, GCF. You should remember this, GCF. GCF can technically happen in any problem ever. So this is a good type of factoring to learn because it can always happen. GCF. All right, so if I have the problem x squared plus 5x, can anyone tell what the GCF is? I'm not being tricky, it's just x. There's an x in both terms. So we're going to take the x out. And if you have an x squared and you take one of the x's out, what is left over? X. And if you have a 5x and you take the x out, what is left over? 5. Okay, so that's GCF. Do we remember that? I am tattling on you. I'm telling Miss Lopez. And Miss McBride. All right. The next type of factoring is trinomials. Where a equals 1. This is probably the most common type of factoring. This is where teachers really hammer it in. This is like the factoring where we're like, you have to know how to do this. All right, we got 3x squared plus 27x plus 60. I did put a GCF in there just because you always are supposed to check for GCF first. Always. So can you guys tell what the GCF is? 3. Okay. So the GCF could be a letter, it could be a variable, but it could also be a number. 3x squared. Some of you guys in the back are a little squinty. Let me see if I can zoom in.
Well, I just don't have my glasses on.
Okay, but even if you don't have your glasses on, that doesn't mean that you're not squinting. So I try to zoom. That's as much as I can zoom.
That is so much better. That is so much better.
Is it really? Oh. I feel like I didn't do a very good job, but I appreciate the encouragement. So we have a GCF of 3, and then what happens? We take the 3, and then what do we have left over? Plus 9. Okay, 27 divided by 3 is 9. Plus 20. Good. Yeah. So at this point, this is where we take the 20, and we're looking for two numbers that multiply to 20, but add to 9. Two numbers that multiply to 20, but add to, this thing. 5 and 4. Now I say this with love. I'm not being a jerk. It doesn't matter if you don't like it. It's for the rest of your math career. I'm for real. It doesn't matter if you don't like it. It is from now on. This is to upper level math what adding is to lower level math. It is, and the thing is, if you can get over a fear of it, it will get to the point where this is easy peasy. If you can get to the point where you do enough of them, you actually understand what you're doing, it will get to the point where factoring is like, I factor, it will get easy, I promise. Okay? Because everybody, this is the thing that math teachers know, everybody hates factoring when they start, and there's a point where it clicks and you're good. You just have to do enough of them, yes. Okay, yeah. Now, here's a calculator trick. If you're like, I'm very bad at multiplying, you can say 20 divided by x. You can put that in your calculator. And then you can go second graph. You can look at the table, and the table will give you all of your options. So these are all the things that multiply to 20, and you just have to find the two that add to 9. So if you're not very good at your multiplication tables, then you can use the calculator to help you find them. So if we're looking for something that multiplies to 20 but adds to 9, doing 20 divided by x and then looking at the table, it will give you all the things that multiply to 20, and you just have to look for the ones that add to 9. So I did 20 divided by x, I did y equals, I did 20 divided by x, and then I hit second graph. So second graph, instead of looking at the picture of the graph, it takes me to the table. And then I can see 1 and 20, that adds to 21, that's not right. 2 and 10 adds to 12. I'm ignoring that one because it's a decimal, and then I got 4 and 5, or 5 and 4. Those are the same. So my two numbers are 5 and 4. I'm going to make sure I got the 3 in the front. And then I got x plus 5, x plus 4. Here we go. Oh, so fun. What a great time I had. All right. Next, we got trinomials, where a does not equal 1. And we call these slide divide, which sounds like a little amusement park ride. It's a good time. Slide divide. I love me some slide divide because people who don't do slide divide do guess and check, and that is not what I'm about. I do not like me some guess and check. No, ma'am. Ugh, I hate guess and check. Okay, so here's the example problem for slide divide. We got 6x squared minus x minus 2. So here's the way the slide divide works. You can see with this one there is no GCF. Do we see how there's no GCF? I got a 6, a 1, and a 2. There's nothing in common there. I mean, 1. 1's technically in common, but if you pull out a 1, you still got the same problem. Between x squared x and no x, there's no variable in common to pull out. So with slide divide, what I'm going to do is I'm going to take the 6, and I'm going to multiply it by a negative 2. So I'm sliding the 6 over to the end, okay? 6 times negative 2 is negative 12. And then I kind of treat it like the last problem. So I'm going to take the middle term, I'm going to put that on the bottom. So this is a negative x, that's technically a negative 1x. So I got negative 1. What multiplies to negative 12 but adds to negative 1? Negative 4 and 3. I do the little x thing because it organizes my numbers and it's how I learned it. Yeah, it multiplies to the top and adds to the bottom. And that's how I learned it. And so you'll see me write my work that way, but you don't have to write it that way if you don't want to. Multiply the numbers to the top, add to the bottom. And then you put the two numbers on the side. You don't have to write your work that way. You don't. Yeah, you'll see me do that on my paper, but you don't have to do it yourself if you don't want to. So the two numbers that multiply to negative 12 but add to negative 1 are negative 4 and 3. So we're going to write x minus 4, x minus 3, or x plus 3. But you'll notice if you FOIL this out, this does not give you 6x squared. Right off the bat, we can tell x times x is not 6x squared. So when you do slide divide, the number that you slid over becomes the number you divide by. I slid the 6, then I divide by the 6. I slid the 6, then I divide by the 6. The 6 was from the beginning of the problem. The slide, anytime you have a problem, so this one, see how it says a equals 1? A is the first, once we took the 3 out, the a was 1. A is the term in front of the x squared. So these I think of as simple trinomials. When you have a simple trinomial, you can just say, oh, what multiplies to the end and adds to the middle. Anytime you have what I think of as a more complicated trinomial, where there's a number in front of the x squared that doesn't go away, you have to do a slide divide. And so you take the number in front of the x squared and you slide it to the end. And then once you've done that, then you have to divide by it. Now, anytime you have fractions like this that can be simplified, you have to simplify them. So 4 over 6 can simplify to what? 2 over 3. So we're going to write x minus 2 over 3. 3 over 6 can simplify to what? 1/2. And then after this, we go bottoms up. So the bottom moves up to the front. The bottom moves up to the front. You don't have to do it this way. You can do guess and check if you want. The reason I do it this way is because with guess and check, you have to guess and check until you get it right. It's frustrating. you get it right every time. You are allowed to do guess and check, yeah. What? Guess and check is where you say, okay, I know the front two numbers have to multiply to 6, so I can do 2 and 3 or 1 and 6. And then you have to have the other numbers multiply to -2, and you just guess until you find the one that works. And some people like doing that method, and I don't, because you can get a lot of wrong answers first. And I don't like that. I like that it seems like a frustrating process, but it's the same every time. So if you were like slide, divide, bottoms up, slide, divide, bottoms up, you just memorize the process, then you're good to go. Yeah. No, that's fine. If you like that, then go with it. I'm not going to judge you. That's fine. All right, here is the next one. Difference. Anyone know what I'm going to say next? Of squares. Difference of squares. All right, I got 5x squared minus 80. 5x squared minus 80. Well, that doesn't look like difference of squares. Why not? Those aren't perfect square numbers, though. 5 and 80 are not perfect squares. You do the thingy. What's the thingy? What's the thingy? Divided by 5. Do the GCF thingy. Okay, divided by 5. So we're going to take a 5 out. That leaves us with x squared minus 16. Okay, so when we see difference of squares, what numbers do we typically see? One is a perfect square with another perfect square. 0 is not a perfect. 4, 9, 16, 25, not 27. 27 is a perfect cube. 36, 49, 64, 81, 100. Wait, what comes next? 169. All right, so once we have this, does anyone remember how difference of squares works when you factor it? You get two sets of parentheses, one negative, one with a positive. And what goes in the parentheses? X plus 4, x minus 4. So you got perfect squares, and then to put them in the parentheses, you just square root them. Yeah. Hello. Huh? No, sorry. I'm sorry. Oh. See ya. All right, here is the one. Here is the one that is new to us. Are you ready? It is sum and difference of cubes. We're looking for cubes now, perfect cubes. Sum and difference of cubes. Sum and difference of cubes. Okay, we're going to write down two formulas. We're going to write one for the sum of cubes, one for the difference of cubes. They're very similar. Then we're going to use the formulas. Sound good? Okay, here's the formula for the sum of cubes. I'm going to write a cubed plus b cubed. Okay, are you ready? All right, the first parenthesis is a plus b. Well, that's nice. The next parenthesis gets a little strange. Are you ready? It is a squared. Okay, not so bad. Minus, okay. AB, okay. Plus b squared. All right, that's okay. All right, the next one. A cubed minus b cubed. Okay? First parenthesis. A minus b. All right? Okay, first one. A squared. Okay? Plus ab plus b squared. Whew, okay, here's how we remember the signs. Are you ready? S. Because this sign is the same as the original problem. Do you guys see that? Same. Okay, same as the original problem. Okay, this is O because this is the opposite of the original problem. Would you guys agree with that? Yes? Okay. What do we notice about this? It is always positive. SOAP. SOAP is our acronym. SOAP. Okay, so when we do sum or difference of cubes, we're going to remember SOAP. It's how we remember our signs. Same sign, opposite sign, always positive. Okay. SOAP. Okay. All right. Okay. Whew. Right. Now, these problems are a little bit more fun if you have two colors. So go ahead and get two colors out. I don't know. Do you have two colors? A pen and a pencil would work. Do you have a pen and a pencil? I mean, I'll give you time. Okay. All right. The first perfect cube. Well, you can go ahead and write down this problem. We're gonna be doing it in just a moment. So 8x to the third minus 27. That's what we're about to start doing. The first perfect cube is 1. 1 to the third is 1. The next perfect cube is 2 to the third. Does anyone know what 2 to the third? It's 8. Okay. 3 to the third. Okay. 4 to the third. Okay. 5 to the third. Okay. 6 to the third. Okay.
343.
Okay.
Then we got 512.
Okay.
Is 8 cubed. And then 9 cubed is 729.
I think so. This is about all that you really need to know. Much bigger than this, and they don't really get that big in the problems. So, but I'd say these are like, especially up to 343. Those are about the recognizable cubes you should know to do these problems. And you can use a calculator. For the most part, it'd be like, wait, what's that cube again? And you could go back and just type it in. But as you can see, they get pretty big pretty fast. Okay. All right, so here's what we're going to do first. When we start these problems, and we're going to do it in colors so you guys can see how the pattern works, because the formula looks funky until you see the pattern, okay? So 8x, 27, I'm going to rewrite this in my two colors, okay? So 8x to the third is really just 2x to the third, right? 2x times 2x times 2x, that's how they got 8x cubed. 7 to the third is really just 3 to the third, okay? 27 to the third, not 7 to the third, 27. 27. Oh my gosh, I can talk, I swear. 27 is really just 3 to the third. There we go, said it correctly. Okay, so to do the problem, we're going to have a small set of parentheses, and then we're going to have a large set of parentheses, right? Okay. So we have two colors. You guys can clearly see there's like half and half, right? One half, another half of the problem, okay? So here we go. We got same sign, opposite sign, always positive, right? Here we go. Same sign, opposite sign, always positive. There's our soap. Let's go ahead and write soap. Same sign, opposite sign, always positive. Everyone got their soap in there? Same. Do not make prison jokes while I'm recording. Same sign, opposite sign, always positive. All right, here we go. So we start off with 2x minus 3. 2x minus 3. You guys got that? Okay. Then it says a squared. What that means is we're going to do 2x times 2x. Everyone see that? 2x times 2x. Okay? We're going to get there in a second. I'm just showing you guys how you can memorize this formula without working very hard. Okay? The next one says a times b. So this one is going to be 2x times 3. And then the next one says b squared. So this one is 3 times 3. You guys see how it's like half and half, half and half? Everyone see that? So when you're having trouble with the formula, get out colors and do half and half. Because you got soap for your signs, and then you got halfsies. Okay? So this formula, it can be pretty easy to memorize if you are deliberate when you first start practicing it. Does that make sense? I don't memorize the formula like this. I memorize the rhythm of the pattern. Does that make sense? I go like A, B, B, B. That's how I think of it when I write this out. A times A times B times B. That's how I write it out when I do this. Yes. Yes. Okay. So my final answer now, I'm going to go ahead and write it. I'm going to clean this up. I got 2x minus 3. And then what else do I have? Wait, what's 2x times 2x? 4x squared. Okay, what comes next? Plus 6x. Okay, plus 9. Now, see how that second set of parentheses looks like a slide divide? It is almost never factorable. In fact, if you said, Miss Rice, find one that we can factor, I would be like, I probably can't. That is how often they are not factorable. It is almost impossible to find one that actually would. Okay? So odds are you'll be able to stop there almost every single time. Okay. How do your brains feel about that? Well, in that case, let's do another one. All right. I'm gonna. Yep. Always. All right. We got 1 minus 729 x to the third. So I'm going to start it off the same way, something cubed minus something cubed. Okay, 1 is what cubed? 1, okay. 729 is what cubed? 9 to the third? Yep, it's 9 to the third. Okay, so this one is 9x. Okay. And actually, I'm going to change this to a plus because we did a minus last time. Let's do a plus. Everyone get that? We changed it? It does because we got to do the soap right. All right. So we're going to do same sign, opposite sign, always positive. I'm going to label it so I don't forget my acronym. Soap. Same sign, opposite sign, always positive. All right. Let's go ahead and fill it in with the colors. So I got 1. I got 9x. All right. Now what should I write? not 9x. I got 1. 1 times 1. Okay? What comes next? 1 times 9x. Okay, what comes next? 9x times 9x. Oops. Didn't really give myself enough space. Okay, let's go ahead and clean it up. All right, so this is 1 plus 9x times what? Oh, I missed my x. Nobody corrected myself? Whew. Okay. All right, 1 plus 9x, there's my first one. And then what do I have? 1 minus, okay, plus 81x squared. Okay. That's fun. I thought it was great fun. That's it. That's it, yeah. When you do the colors, the formula is not so bad. Do you need to what? It's great to like put it in a different order, but this is mathematically accurate. It's just that like people in college will be like, "Oh my gosh, they didn't reorder it." Yeah. So, yeah, we got that.